Hey, you, there, Dino.
Uh, yes, sir?
I don't like you, Mr. Dino.
Well, why? I mean, we've never met before. I, my name's Henry. It's nice to meet you. Who are you?
I'm Sheriff Paddington, and this here is my town.
Oh, okay. Well, it's a pleasure to meet you, Sheriff Paddington, sir. Could you help him to show me where the...
Get out of my town, Mr. Dino. We don't like your dino friends and your dino kind people out this way.
Oh, well, I'm sorry to have bothered you. I mean, I thought we could both fit in here, but that's fine. I can leave.
That's right. You just keep on walking and you talk to all your other lizard friends and you get...
Hey there, guys. Welcome to another Year 10 Geography lesson. Today, we're going to be continuing on practicing a bit of data analysis and using some computer software to represent different types of information. In the last lesson, we got really good at starting to develop graphs using carbon dioxide emissions, and you guys were able to create an incredibly massive graph based on like 24,181 pieces of data. So we're not going to be doing quite as massive a data set today, but what we're going to challenge ourselves to do is to try and fit two sets of data onto the one graph. So we'll see if we can make that work. Thank you for my friends Dino and Paddington, and thank you for my Bubba Boy for lending them to me. So what you guys need to do is go to Compass and download the document Graphing Multiple Data Sets on One Graph. Hopefully you've already done that. And what you're going to be doing is taking a look at these two sets of data here. We've got atmospheric carbon dioxide concentration, and we've also got average global temperatures. So what we're going to be doing is creating a graph using these two different sets of data. Now, you're going to notice that these data sets don't perfectly match up, and we're going to figure out if we can make them sit side by side and work with our graph correctly. The first thing I want us to do is just take a look at the data here and just see if we understand what it is that we're looking at. So as I said, this first stuff on the left here, we've got atmospheric carbon dioxide. We know what that is now, and it's in parts per million, so that's the concentration. So how much we have in a certain amount of space or in a certain amount of air. All right. Over here we have our year, so this is being tracked from the year 1000 all the way down to 2012, all right, as you can see down here, all the way down to 2012. You'll notice that our temperatures don't go quite as far. We're just going to start our temperatures here at 1880 because that's where we actually have physically recorded temperatures rather than our estimates based on all of this other data. We've actually got direct evidence based on the temperatures in the same way that we've got direct evidence of the CO2 all the way back there as well, okay? So what we're going to be doing is creating a graph just from 1880 onwards so that we can look at basically the consequences of industrialized society. So if you guys remember from Year 9 history, if you got to do it, the Industrial Revolution was when we went from just farming and making things by hand to using machines and steam power and coal, right, and burning of fossil fuels in order to do all of our work for us and mass produce things. So we start the dawn of factories and enormous buildings and enormous mines and things like that. And so we're basically tracking if our human activity and our increase in industrialization, therefore our increase in carbon dioxide emissions, has any impact on whether there's going to be a rise in temperature or not. So that's hopefully what our graph's going to look at today. And if it looks like they match up, well, we might see a bit of a relationship between those two things. So the first thing I want us to notice as well is our temperature here is in degrees Fahrenheit, so you probably don't really know what that means because we're not Americans. Typically Americans use Fahrenheit, we in Australia and a lot of European nations and the West use degrees Celsius. So what I decided I could do was just calculate all of those temperatures into degrees Celsius for you to start with, or I could just show you a little trick and just show you a little bit of how Excel works. The fact that we are really we're doing calculations and we're showing that, well, I could do all these sums really quickly, or take a long time and do it myself, or I could make the computer do it for me. And I think I'm going to get you guys to try and do that yourselves. So what I want you to do is, so we've got our equation here that to calculate degrees Celsius from Fahrenheit, Celsius equals, brackets, our Fahrenheit minus 32 divided by 1.8. All right, so that's our equation there. We can actually create an entire column here without having to do every single equation ourselves. Just put in the equation once, copy that all the way down, and I'm going to show you how that works now. So what you're going to do is, let's say we wanted this column here to be Celsius. Whoop, if I can type correctly. There we go, Celsius. And we're going to pop them right next to our Fahrenheit temperatures. So what we're going to do now is try and use this equation here to calculate all of our Celsius temperatures. Now, what we're going to do is press equals the sum of whatever we tell it to. So we're going to do the sum of brackets, right? Whatever we select in here, it will calculate that for us automatically as a sum. So if I, for example, just wanted to say, what are all these temperatures add up to that I select here? I'll put them in there, and brackets, cool. That'll tell me the total of all those things, but that's not very useful for me right now. I'm just showing you that's how it works. Let's go, what we really want to do is we want to put this equation in here, and this F is going to represent that temperature there. So we're going to go equals sum brackets. Now we're going to click on this cell here, so this is our G6, right? So we're just going to click on that one, G6 minus 32, and then close our brackets, and we want to divide that by 1.8. So let's see what that gives us in the end. 13.78. Now, I've checked all these before, and I know that that's absolutely correct. Another sneaky thing that we can do now is, you don't want to have to type in that whole thing every single time, do you? We have a little fantastic function here. If you move your cross all the way down into the bottom, it comes up with a little black cross. That actually copies what's in that cell all the way down. Now, you might be thinking, well, they're not all going to be 13.78. Correct, because we're not copying 13.78 into all these boxes. We're actually copying that equation into all these boxes, and it's going to copy it for the one that's right next to it. So see how we've got a different number every time? Let's look at this one. This is using G138, so it's actually pointing to that box there, G138, and this one would be 137, etc. So how cool is that? That's a little trick for you guys. So we've done an equation. So now we've gone for all of our temperatures from degrees Fahrenheit to degrees Celsius. So that when we as Australians look at our graph, it makes a lot more sense to us rather than looking at it in Fahrenheit. Okay? So our next step, let's get to graphing, okay? It's not a brand new skill because you already know how to map, for example, the concentration of something versus the year. We did that in the last lesson. So we're going to do the exact same steps as last time, but because we're mapping two different things on the exact same graph, we've got to make sure that we are being careful about the steps that we take. So our temperature here starts at 1880. So there's really no point in us starting our concentration as part of our graph in 1000. So we'll probably want to go all the way down to 1880 and select all the figures from 1880 below. Okay, so let's get our graph started. Let's get going. So I'll press, as you know, insert. We're going to go across to, we'll start with a line graph. That'll be easy enough. Let's just put it like this. We're going to change the format of the graph shortly. Okay. All right, but I want to do it this way just to show you something, just to show you why it won't 100% work. If we try it this way, we'll have to fix it. All right. As always, we're going to go design. Remember, not Acrobat, not format, design, straight in the middle. Okay, select our data. Now, as I said, we want to select our data from 1880 below. All right, so we're going to add our entry here. Series name, we want to do carbon dioxide first, CO2 concentration. Or we might even call it atmospheric. Oh, I always do that. Don't press arrow keys while you're in this because it starts moving it about the field. Atmospheric CO2 concentration. Fantastic. Delete whatever's in there. And now we need to go down and select all of the ones that we want. So all of the 1880 concentrations and down. Check this out as a neat little trick. You learned this one the other day. I can click on, so right next to 1880, this concentration here. I'm going to start there, Control, Shift, and down. That's going to select all the values all the way down, except it's not going to do the infinite values if we had to press B, for example, right? So we've got all the ones that we want in there. We're going to press OK. Fantastic. Now we've got we don't have an issue. We just need to make sure we fix it. Okay. It's going to do on the horizontal axis, our x-axis, 1, 2, 3, 4, 5. But we don't want that. We want that in years. So let's edit this. All right. We want to make sure that that's showing 1880. Oops. Let's go back down here. All right. 1880 all the way to 2012. So we're literally going to click again, 1880, click on that box, Control, Shift, down. That's going to select all those numbers, and they're the numbers that it's going to put into our graph. See how it says it here? Perfect, that's exactly what we want. Let's see if that comes up nicely on our graph. Gorgeous. All right. So see our graph here starts at 1880, goes all the way up to 2010. It'll go a bit further if we give it some more space. There we go. All right. So the smaller we bunch it up, the more dramatic the curve will look, but that's fine. We'll try not to cheat the data. Okay, so we've got one of our sets of data on here already. That's fantastic. So make sure you pause and have a go at that yourself. Maybe even challenge yourself to try and do some of these things before I show you how to do it, because you already know how to do this first step. That's awesome. All right, next step is we're going to add our temperature to this graph. So going over here, we're going to go design again, select data. We want to add in an extra set of data. So series name, let's call this temperature degrees Celsius. We'll make sure it's Celsius so that whoever's reading it knows that it's Celsius. All right, and the data that we want to select, let's go to the top. We want the Celsius, remember, not the Fahrenheit. So click on this first one, Control, Shift, down. I'm going to select every bit of data all the way down, and it stops at our very last point. Cool. And again, you can see here that we might have an issue with these numbers here. We want to make sure that's still staying at 1880 and going down to, or going all the way up to 2012. So we might have to do that again just to make sure it's not being silly. Now we can do that based on the numbers here as well. We don't actually have to do it all the way to the left. We could do it these ones here. Click, sold. See how that works out? Same as this one, works out gorgeous. Let's see what our graph looks like now. Now I'm going to spoil it. It's not going to be perfect, but it's going to be okay to start with. All right. So this is what we should expect to happen because we haven't done a really important step. So as you can see, our CO2 looks pretty good. That's correct, isn't it? So if we go to 2010, 2012, we should be looking at around almost 400. Let's see if that's correct. Almost 400. Fantastic. So we know that we got the right numbers in there for our CO2. Do we have our correct numbers in here for in terms of our temperature? 1880, 13 degrees. Yep, that's about 13 degrees. Let's think to ourselves, why is this orange line down here and so low and thin? And how can this help us to learn anything about the relationship between these two? The big problem is, as you can see, it's only using this number scale on the left, right? So this is obviously going to be very low. Even if things are changing for the temperature and going up and down, we can't really see that because it's trying to stick to these big numbers over here. So it's still an accurate graph, but it's not a helpful graph, okay? What we really want to do is make sure we have another set of numbers over here on the right-hand side, all right? And that can be our temperatures. Okay, so guys, as you can see, what we really want to have is our lines against one another so that we can see these rise and fall. It's not giving us enough space to really see the changes in the temperature here. But what we can do is change the graph itself so that we're showing two different sets of numbers or ranges so that we can actually see the temperature change a little bit better. So we're going to click on Design. We're going to change the chart type. So look at all of our options here. We can go line, pi, bar, area, blah, blah, blah. What I want you to do is go all the way down to combo because we want to do a combination of two bits of data together. And what we really want is a secondary axis over here. So not just this CO2 concentration, we want the temperature over here. So click on whichever one, doesn't matter. You could have the temperature on the left side, or you can have the concentration on the left side. It's up to you which one you want to do. I prefer to have the temperature on the... Whoops. There we go. I prefer to have the temperature on the right-hand side and the CO2 concentration on the left-hand side, just because you've got bigger numbers over here. Not a big deal. You can do it either way and it'll work. So as you can see, this shows us a little bit better the numbers side by side and the changes side by side. You can do a bunch of different styles there if you really like. Ideally, you just keep a straight line so that we can see that very, very clearly. Okay. So there you go, guys. This should show us a really awesome graph. Now, you'll see that a couple of things seem to be missing now, our years and all that sort of stuff, and some labels. That's just a formatting thing. If you go over here and click, design, we can, as soon as you change it to another design here, it actually looks pretty rad. Check this out. Bang. All right, I really like this style. It sticks out with these colors pretty well. We've got our CO2 on the left-hand side, our temperature on the right-hand side, and we've got our years from 1880 to 2012. That looks really awesome. One thing that you can do is you can also add axis titles, so that if you wanted to, for example, put over here, select that CO2 concentration, or you could even do atmospheric CO2 concentration, that's fine too. Over here, double click, we want temperature in degrees Celsius, Celsius, fantastic. Almost there, we'll go year. Now there's a cute little thing that you can do as well if you wanted to add a legend. That looks very good as well, so that we can show what color represents what. Okay, so our temperature is in orange and our blue is our CO2. Now, what I want you guys to do from here, you can decorate it and make it as pretty as you like. You can also add a title, a chart title, so you can pop something up there. It might just be like CO2 and temperature over time. Or you could say, from 1880 to 2012. Okay, there you go. You've got a fantastic graph here. We could make it look all sorts of pretty. Let's see if there's another pretty one that we can look at. Yeah, you can make it white, a different sort of white, grey. Okay, they're not all super pretty. I'm sure you could fill it out in some other sorts of way, but that's totally up to you how you want to style that up. Ooh, our colours. Oh yeah, check that out. So I really like colours, and I like messing around with things like this. Bang. All right. Anyway, okay. So what I want you guys to do now, please, is having a look at this graph. I want you to write just a couple of sentences to me explaining what we can learn from this data. Is there a relationship between CO2 change and temperature change? Right. I mean, it probably looks very obvious, but I'd like you to explain it to me, please. And what I really want you to do is also show me in your answer, point out a couple of specific points, maybe choose at least 3 points to sort of back up your answer and why you think there may or may not be a relationship there. Okay? All right. All the best, guys. Thanks very much for tuning in. And I hope you're starting to enjoy the success of Excel. It's kind of fun when it starts to work for you and you can get all these tips and tricks going. The power of computers is very, very impressive. All right, bye.